Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. This is a video on tips and tricks. In this video, you will find a shortcut method to find the roots for quadratic equations that can be factorized. Consider this equation and let's solve this using factorization method. First, you will find the product and sum from the quadratic equation. The product is multiplication of these two numbers, which gives you 6, and the sum is the number in the middle, which is 5. And you will find two numbers which on multiplication will give you 6 and on addition will give you 5. So the numbers are 3 and 2 in this case, which satisfy both the conditions. 3 multiplied by 2 gives you 6 and 3 plus 2 gives you 5. And you will split the middle term into 3x plus 2x. The 5x which is in the middle will be split into 3x plus 2x, and the equation will be written like this. And then you will simplify the equation, factorize it, and solve individually as x is equal to -1 or x is equal to -2/3. And this is the way you do when you are asked to solve this equation by factorization method. Okay, let's see something special from here. When you divide by 3 by -3, you get -1, which is one of the roots. And if you divide this 2 by -3, you get -2/3, which is the other root. So where is this -3 coming from that we are dividing here? You can see that the leading coefficient of the equation is 3, and therefore the -3 is nothing but -a, where a is the leading coefficient. Therefore we are dividing by the opposite sign of the leading coefficient to get the roots. So let's consider another example and see if it works. This is the equation. So product and sum. Product will be -10 and sum will be -9. So choosing the number accordingly, you will have -10 and +1, which on multiplication will give you -10 and addition will give you -9. Therefore, the middle term is split into -10x plus x, and simplifying further, you will get these two factors. Solving those two factors individually, you will get x is equal to 2 or x is equal to -1/5, which will be the roots of the given equation. The leading coefficient here is 5. Therefore, we have to divide each of the numbers that we chose by -5. So, -10 divided by -5 will give you 2, which is one of the roots. And +1 divided by -5 will give you -1/5, which is the other root. So, actually this works. Once you find the numbers for product and sum, you just need to divide those two numbers by the negative of the leading coefficient, and then you will get the roots. Let's prove this in general. Ax square plus bx plus c equal to 0 is a general form of quadratic equation. And the product is ac and the sum is b. So you will find two numbers m and n, say, so that m times n should give you ac and m plus n will give you b. That is the way we proceed. And you will split the middle term bx into mx plus nx like this. Now let us divide this equation by the leading coefficient a. Now we have AC equal to Mn because m times n gives you AC, and therefore C is equal to Mn over A. That is going to be substituted in the place of C in the equation, which gives me the constant as Mn over A square. Rewriting this as x square minus of minus m plus n over A, I am just changing the plus into 2 minus here, and the remaining things are left as it is. Now I am going to split this further like this. Minus of m plus n over a can be written as minus m over a plus minus n over a, and mn over a square can be written as minus m over a multiplied by minus n over a. Why I am writing this? Because we know that x square minus alpha plus beta x plus alpha beta equal to 0 is the quadratic equation when alpha and beta are the roots of the equation. So you can now compare the equation in green with the last equation that we just did, in which case alpha is -m over a and beta is -n over a. Therefore, alpha is m over -a and beta is n over -a, which means the m and n are the numbers that we found for product and sum, and if we divide them by -a, we get alpha and beta, which are the roots of the equation. So it does work for any general equation ax square plus bx plus c. So let's continue and check this out. We have this equation. The product is 14 and the sum is -15. So you will choose the numbers as negative 14 and negative 1. And now by the proof that we just did, we have to divide this by negative of the leading coefficient, which is 7. Therefore, dividing it by negative 7, each of those numbers, we should be getting the roots. The roots should be 2 and 1 over 7. So there is no need to factorize anymore. You just have to find the numbers for product and sum, divide by the negative of the leading coefficient, and you will get the roots. Let's consider another example with negative leading coefficient. Here in this case, negative 4 is A. The product will be minus 20 and the sum would be plus 1. The numbers you would choose here are plus 5 and negative 4. Now the leading coefficient is negative 4, so dividing by negative A means dividing by negative of negative 4, which is positive 4. Divide the numbers that we found by positive 4 and we should be getting the roots. Therefore the roots are 5 over 4 and negative 1. So you have just learned how to find the roots of a quadratic equation when they are factorizable. So you just need to find the numbers for product and sum, divide each of them by the negative of the leading coefficients, and there you get the roots. Hope you enjoyed this. Thanks for watching. Subscribe to Ganitika.com and to our YouTube channel.